Hello ladies, so today we're going to go over some of our trig integrals, and just like we did with trig derivatives, we need to make sure we review our trig identities. So here are some basic trig identities, and just to make sure we remember what they are. 1 over sine is always the same and can be rewritten as cosecant of x, whereas 1 over cosine can be rewritten as secant of x. And 1 over tangent is our cotangent of x. And just to take a look, anytime I have sine over a cosine, I can always rewrite this as tangent of x. And anytime it's the reciprocal of that, you will see that it's actually the same as cotangent of x. So these are some identities you want to keep in mind when we're doing some of these trig integrals. The more you can simplify a trigonometric function, the easier it is to use the given integrals that you will see in the next page. So just like with our basic integrals, we know that we need integrals to undo the derivatives that we have. So if you take a look at these, you already seen these patterns, except now you are going the opposite way. So for instance, the derivative of sine is cosine, so the integral of cosine is sine. Same thing, the derivative of tangent is secant squared, so the integral of secant squared is tangent. And if you take a look at these, this also follows the same pattern. Let me grab my highlighter here. Anytime you take an integral and it is one of the functions that start with a c, you notice your sign is going to be negative. So it's the same exact rules as before, except now we need to make sure we're going the opposite way, okay? So let's go ahead and take a look at some of these integrals, and we are still allowed to use the basic integrals from last class, or actually from 2 classes ago. So if we take a look at this, I see a couple of things. I see I have constant multiples. I also see I have powers, I have constants. And in this case, especially because this is trig, you notice our variable has to be a theta. So once we take our integrals, we have to make sure we integrate these as thetas. So the first thing you notice is I can actually take these integrals piece by piece because I have plus and minus signs in between. And because we know that rule is possible, we're actually going to do these one step at a time. So if you notice, when I have 2 sine theta, 2 is a constant, so I'm allowed to pull that out. And according to your previous list, the integral of sine of x, or sine of theta in this case, has to be negative cosine. So I'm going to stick a negative out here and mark this as cosine of theta. Then if I move on to the second piece, I again have a constant. I have a constant negative 3. Then I need the integral of cosine. According to our list, the integral of cosine is sine of theta, so I'm allowed to put sine of theta right here. And then if I continue on, I get a theta squared. So this actually doesn't use any trig identities, but I do use the power rule. I know I have a theta squared, which means I make it a theta cubed because I add 1. Then I divide by the power, which gives me theta cubed over 3. And finally, our last step is I have a constant. Since this is a constant pi, I know it would become pi, and I stick a theta at the end. And like always, I add a plus c. So in this case, the only time we used the trig functions were in the first 2. And all I did was match them up to the integrals that were given before. All right, let's take a look at the next one. You notice I have a set of parentheses here. So just like in basic integrals, I'm going to want to make sure I distribute this. So if I distribute this, I'm going to distribute this entire 2 cosecant of x to everything in parentheses. And I get the integral of 6 cosecant squared of x, let's take parentheses right here. 2 times negative 4 is negative 8 cosecant x cotangent x. And the last piece is a positive 2 cosecant x sine of x. And this is a dx right here. So I take a look at our properties. For our first piece, I notice I have a constant, so I'm allowed to pull out the constant. Then I check if I have an integral of cosecant squared. And according to our list, that is the same as negative cotangent of x. Then I see for the next piece, I have a negative 8. And then I want to check if I have a cosecant x cotangent x. Once again, according to our list, that's a negative cosecant of x, which changes this to a positive, and this becomes a cosecant of x. And for this last step right here, I'm going to pull out that 2. And then I check if I have a cosecant x sine of x. And if you notice, that's not one of our basic trig integrals. So what I'm going to do is I need to rewrite. I'm going to just copy this down right here so I know what I need to rewrite. So the question is, what trig identity do I know which can simplify this? So if I take a look at my list, I can see that cosecant is actually the same as 1 over sine. So what we're going to do, and let me scroll down here just a little bit, I'm going to rewrite this entire thing, negative 6 cotangent of x plus 8 cosecant of x plus 2. And if I want to rewrite this, I'm going to rewrite this as 1 over sine of x, which is on our list. And I'm going to keep everything else sine of x dx. Once I rewrite this, what do you notice about this sine of x in the denominator and this sine of x up here? You're correct. They cancel. And so what I get is negative 6 cotangent of x plus 8 cosecant of x plus 2 and the integral of dx, which is just x, and then I get my plus c at the end. So although it looks complicated, when I rewrite it, it actually simplifies a lot better. So we're going to do the same thing for the next 2 problems. And if you notice here, I have a denominator. So what we're going to do is we're going to see if there is something that I can do to rewrite this. And if you take a look, you notice our variable in this case is a u. So make sure you write everything with u. First of all, I know I'm allowed to pull out that 7 because that is a constant. And what I have left over is this cosine u over sine of u du. So I take a look at our list, and if you notice, we always want to make sure we try to get rid of our denominator. Sorry, I'm missing a u right here. So what identity matches a sine of u in the denominator? Good, I have 2 options. I have a cosecant. I also have a cosine over sine, which is a cotangent. So according to what I have, I notice not only do I have this sine u over here, but I also have a cosine u here, which leads me to want to use my cotangent integral. So if I rewrite this, this yellow portion is going to be rewritten as a cotangent. So I get 7 integral cotangent of u cosecant of u du. Then I check my basic integral list and I notice I have a cosecant cotangent integral, which gives me a negative 7 cosecant of u plus c. And you're done. And finally, let's take a look at the last problem. Once again, I have a denominator, but now I notice I have plus signs and minus signs in between. So just like we normally do when we have a denominator, we're going to try and break this up and then simplify it. So I get the integral of cosine of x over cotangent of x plus a secant of x, secant of x over a cotangent of x minus an integral of cotangent of x over cotangent of x. And all of these must have that dx at the end. This third one is actually the easiest one because I noticed that these cancel. So this can be rewritten as minus integral of dx. And then we take a look at these next two, and I want to get rid of this cotangent. So the first thing I notice is, on this case, I don't have a problem that has a cosecant and a cotangent. Technically, I could use cotangent in my denominator, but let's actually flip this around just a little bit. And what I'm going to do is I'm going to get a cosine of x. When I have a cotangent in the bottom, we notice that's the same as a tangent on top. There's multiple ways to use these, right? Over here, I'm going to do the same switch. Secant of x, this denominator gives me a tangent of x at the top, dx, and then we have that right there. I have an integral for this, and I have an integral for this, but I still don't have an integral for this section right here. So what we'll do is let us rewrite our cosine of x as its other identity, which is a sine of x over cosine of x dx. And if you can see where I'm going with this, these cosines cancel, right? I already know the integral for this, which is going to be my plus secant of x. And I also know my integral for this, which is an x. I'm going to add my plus c at the end so I don't forget it. And finally, all I need to do is take the integral of the sine of x. So we know that the integral of sine of x is negative cosine of x. And I'm going to bring everything down to get our final answer. And that's how you do your trig identities. So what I'd like you guys to do is, in your blueberry packet, I'd like you to please try out, let's say, 2 through 10. And I'd like you to do the even ones. And then for homework, let's do 1 through 19 odd. All right, good luck, ladies, and thank you for this lecture.